Becka Lippert, and I'm a product designer on the Secure team. And today I'm going to be talking about SAST Configuration UI. So first off, what is SAST? SAST stands for Static Application Security Testing, and it's one of the many security controls available through GitLab security offerings. SAST analyzes your source code for vulnerabilities. So GitLab checks the SAST report and compares the found vulnerabilities between the source and target branches when a pipeline runs. So an example use case of this would be your code has potentially dangerous attributes in a class or unsafe code that can lead to unintended code execution. Having exposed vulnerabilities in source code can open up your applications to hackers stealing sensitive data. So we want to avoid that at all costs. So the problems that we were specifically trying to solve with the SAST Configuration UI initiative breaks down into two parts. The first is enabling. So previously, the security and compliance configuration page had a link to the documentation where the user would have to go back and forth to gitlab.com, manually following directions and copy and pasting commands in order to enable SAST. The second part is configuring. Previously, users could only configure SAST in order to get more accurate results by locating and editing the SAST GitLab CI YAML file. To complicate things a little bit further, if a user has auto DevOps on, this file isn't exposed at all, and I'll walk you through that in a bit. So even when the user can access this YAML file, we're unable to offer any kind of information about each variable, guidelines or parameters we suggest staying within, or any logic checks or dependencies with regard to how the variables interact with each other. This also means that the user wouldn't know if their configuration was successful until a pipeline was run, where they may or may not see errors arise. So in a nutshell, it's a lawless land, the Wild West of configuration, and we're turning it into more of a civilized society, if you will. Okay, so let's look more closely at enabling. The image here on the left is what our configuration page looked like prior to any SAST configuration UI work. You can see the security and controls we have, SAST, in addition to DAST, dependency scanning, container scanning, etc., and the status column on the right. So you can see none of these are yet enabled. On the right, we have the status not enabled, but instead of a link under more information, we have, ta-da, an enable button. And we'll see what that looks like if that's clicked more in a bit. So link to GitLab docs becomes keeping the user in the UI, providing configuration options, guidance, and logic checks in one short workflow. So the problem to solve around configuration, as I previously mentioned, this is what it looks like before. On the left, you have a bunch of code, and it's the Wild West. So you have to go in between the docs if you want to better understand what each of these variables does and what adjusting any of these levers may or may not do to the way that SAST runs. However, on the right, we have the SAST configuration UI, which is where you go after you click that enable button that we saw on the last page. And so from there, we can offer more of a step-by-step flow in a form layout that provides more context about each variable and guidelines if we have any. This comes pre-configured with our recommendations, but the user can change them if they'd like to. So now let's do a demo. I have a test project here, and we're under security and compliance on the configuration page. So we can see that SAST is not enabled, and luckily now we have this enable button, but previously it was one of these C documentation links. So let's let's enable SAST the old way first and pretend that enable button isn't there. So I would have to go into files. I can see here that there is a GitLab CI YAML file. If I click into here, we can see that the SAST template is included, but we can't actually configure those variables because it's a template include, and these variables aren't exposed here. So what I would have to do is go back and add a new file, select template type. I'm going to add a GitLab CI file, and the template is going to be SAST. So once we do that, then we can see here are all the variables that I have to work with. We can read more about this by copy and pasting this into our browser and reading through the documentation that breaks down what exactly these variables are. So there's a lot to consume in here. If I wanted to change anything like the stage that SAST runs in, I could do that and then click commit changes, and then a pipeline would run, and hopefully that would go through successfully without errors. So that is the old way of doing it. Now let's look at what this looks like from within the configuration page. If I click on enable, I'm seeing these variables in here for me. This is our MVC, so there's a lot more to come. We also have a link to a feedback issue up here. But essentially we're providing some guidance here on what these variables are, and this will continue to iterate. We could have different kind of input controls like steppers, and offer error message and things like that if something's not looking right. So from here we can create a merge request and submit the merge request. So those are the changes that we've made. So let's break this down a little bit more. The configuration UI template basically breaks down all of the variables into two primary sections. One, the reddish orange section at the top, is the GitLab layer configuration. So GitLab takes the 12 or so open source analyzers that go into our SAST offering and applies a wraparound for it for consistent results. For example, each analyzer has their own criteria for severity, critical, high, etc., and some have no severities at all. So when we show results from all of our scanners, SAST, DAST, dependency scanning, etc., we want critical to mean the same thing across the board. Now, the second section is the individual analyzer layer configuration. So each analyzer works on a different language: Bandit for Python, Brakeman for Ruby on Rails, etc. When a pipeline runs, SAST automatically identifies the language used in the file trying to be merged, and those analyzers go to work scanning for potential vulnerabilities. So there's two layers that you can configure at: the GitLab layer that applies to all of the individual analyzers, but you can also customize the individual analyzer. So what do some of those variables look like? One example from the GitLab layer is excluded paths. So any vulnerabilities found in these paths will be excluded from the generated output. And this is helpful for developers who want to reduce noise from the list of vulnerabilities found, for example, in a test directory, which might have intentional problems like developers' tooling or scripts and things that won't get deployed into a production instance and thus pose no risk. One of the examples in the analyzer section, if we look at Flaw Finder, Flaw Finder looks for vulnerabilities in C and C++ source code, which can be configured to ignore vulnerabilities under a set risk level. So by default, we set this at 1, meaning that we only ignore vulnerabilities that Flaw Finder identifies as no risk. But some projects may have less vulnerable data in it, in which case a user may only care about the highest risk vulnerabilities. So they may want to set this to a 3 or even a 4. So all of these solutions were research-driven per an ideal UX process. And I have a link at the bottom of this slide to our SAST Jobs to be Done research insights in Dovetail if you'd like to look at that in more detail. But at a high level, for the purpose of this showcase, I just want to mention that we talked to 6 research participants who validated that security analysts and developers wish they had the ability to tune the rules and thresholds and customize the vulnerability results by applying their own org's policies per project group or instance. Almost all of the participants have to contact their tool support team to configure on their behalf, which adds friction and lag time to the process, whereas we're giving the power directly to the user themselves. And this is a list of our finalized jobs to be done that came out of that research initiative. You can see that 5 of them, 2 primary, 3 secondary, apply to configuration. So the first one in primary in purple, third one down. When I want to get the most relevant findings from my scanner, I want to tune it in a way that works best for our org so that we don't waste any time sorting through false positives or unimportant findings. The next one is when I want to start incorporating security into my org, I want to integrate it seamlessly into my existing workflow so there's more likelihood it will be used and without disruption. And then next we have when I've tuned my scanner, I want to feel confident that it works properly so I don't worry that I broke something and that it will compromise the application security. When I'm reviewing the security configuration of projects, I want to see what changed, when it was changed, and who changed it so that it's auditable and can understand these changes. And when I'm enabling my scanner, I want to understand what's being covered so that I can make sure I'm meeting compliance needs. So, summary, the positive outcomes. One is that the combination of the newly prominent enable CTA, in addition to the fact that we're keeping users in the product rather than having to navigate to docs and follow instructions for the entirety of the workflow, will prompt more users to enable SAST and thereby take more advantage of ultimate features, thereby showing its value. We also just brought SAST down to core in addition to secret detection, but the configuration UI only exists at the ultimate level. And that's to make sure that we're still offering value in our higher tiers. Secondly, users will be more satisfied with their SAST results because they're able to configure it to their orgs or even to each individual project's needs, leading to greater efficiency and more trustworthy or reliable results. For example, fewer false positives. Logic checks and in-context guidance will help the user avoid errors. And by surfacing the configuration file history, users can keep track of what was changed to the SAST file and by whom in case they need to troubleshoot a SAST-related issue. And finally, the development and design effort that went into this initiative can now be easily duplicated by the other security controls and scanner types throughout Secure and Defend. So looking ahead, we are going to be bringing more SAST configuration variables into the UI. We're going to build a configuration UI for secret detection, which is also under the static analysis umbrella. We're going to be looking at how to configure SAST files at the group and instance level, continue to collect feedback from the GitLab sec team, and external users, and iterate for continuous improvement. We will be exploring the idea of pre-configured templates that users could apply, and we'll be doing more exploratory research and designs, which are already underway for a settings area of Secure and Defend, which will include policies which are crucial for compliance as well as workflow preferences. So that's all I have. If you have any questions, please reach out to me in Slack or one of the related issues that I linked at the bottom of the previous slide. Thank you.